where A is the first term, R is the common ratio, N is the number of terms and Tn is the last term. This formula will be giving you a sum to n terms. This is a formula R is lesser than 1 and this is a formula when R is greater than 1. If R is lesser than 1, this is a formula R to the power of n approaches 0 as n approaches to infinity. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics faculty at Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. In the last session, we have learnt how to solve the problems on AP. So in this session, which is session number 3, and here chapter number 5, you are going to have progressions. What are the topics under this session we are going to study, dears? It is nothing but definition of a GP. GP means geometric progression, and then nth term of a GP, and then sum to n terms of a GP, sum to infinite terms of a GP, and problems based on this all formulae, right? So now let us move on to what is a definition of GP. GP is nothing but a geometric progression is a sequence in which the ratio, that is A by B, you are going to call it as the ratio of a term and its preceding term is a constant. So in an AP, the difference between succeeding and the preceding term was a constant, but in a GP, what it is? It is a ratio of a term and its preceding term is a constant. The constant is known as your common ratio, okay, and is denoted by small letter r. This you need to remember. And then this is an example I have taken. 2, 8, 32, 128 form a GP, that is where 2 is the first term and the 4 is the common ratio. How 4 is the common ratio? 8 by 2. 8 by 2 will be is equal to 32 by 8 is equal to 128 by 32, which will be is equal to 4. You can take the ratio between 8 by 2 or 32 by 8 or 128 by 32, which will be giving you the same constant. Understood? This is what you need to learn. Now, we'll move on to nth term of a GP. Now, here I am taking let first term denoted by T1, okay, which will be is equal to A into r to the power of 1 minus 1, which is nothing but a r to the power of 0, which is equal to a r to the power of 0 is 1, a into 1 is a only. This is the first term. We'll move on to the next term, which is second term of an GP. Second term of a GP is T2, which will be implies a r to the power of 2 minus 1, which is equal to a r to the power of 1, which is a r. So first term is nothing but a and second term of a GP is a r. What will be the third term? Third term, which implies T3 is equal to a r to the power of 3 minus 1, which is nothing but a r square. So one term is decreasing there. T3 means a r square, T2 means a r, T1 means only a. That means what will be the nth term, dears? Nth term will be is equal to nth term of a GP is given by the formula Tn will be is equal to a r to the power of n minus 1, because if it is n terms, one term is decreased, that is n minus 1. So this is a formula for nth term of a GP, where a is the first term, r is the common ratio, n is the number of terms and Tn is the last term. Understood? So this you have to remember. Now you came to know the formula of the nth term of a GP. We'll move on to the next is nothing but sum of n terms of a GP. That is a geometric progression. Now here I am taking let sum to n terms is denoted by Sn, okay, which implies that summation of all the sequence, which is a, all the terms ar plus ar squared plus etc. plus last term is AR to the power of n minus 1. Now here I am going to name this equation as 1. So, and again multiplying this equation 1 by r, which implies multiply by r into s to the power of n. This is AR plus this will become AR into r is AR squared plus this will become AR squared into r is AR cube plus etc. plus this will become AR to the power of n minus 1 into here AR to the power of n minus 1 into r to the power of 1, which implies AR to the power of n minus 1 plus 1 minus 1 plus 1 will go. Remaining is AR to the power of n. So the last term here AR to the power of n. Understood? So this equation I am calling as 2. Now here I am going to take it as subtracting equation 1 and 2, that is equation 1 minus equation 2. What it will be giving you? Sn minus r into Sn, which implies you can see here A minus AR, it will be again plus AR minus AR plus AR squared minus AR squared. So therefore leaving the first term plus AR, this R and this AR squared, this R squared, subtracting these two equations. Okay. So this will become here subtraction, subtraction, and the last term here before it will be AR to the power of n minus 1 you are having. So before term here it will be AR to the power of n minus 1 will get cancelled. AR cube will be here, AR cube will get cancelled. So remaining is nothing but AR to the power of 1 with the minus symbol. Now you are going to have this will be is equal to, first is positive A, here remaining in the second term is minus AR to the power of n. Now therefore you can take here Sn common factor, which will be Sn into 1 minus r, which implies you can take here A as common factor, 1 minus r to the power of n. So what it will happen, you can take Sn as it is and remaining 1 minus r you can cross multiply. So A into 1 minus r to the power of n divided by 1 minus r, where here r is lesser than 1. So this is a formula for sum to n terms of a GP when r is lesser than 1. Ma'am, what about when r is greater than 1? When r is greater than 1, it is given by the formula Sn will be is equal to A into, here will be ulta, that is r to the power of n minus 1 divided by 1 minus r will become r minus 1. So this will be the formula of sum to n terms of a GP when r is greater than 1. Where here r is a common ratio, n is the number of terms and a is the first term. Okay, this formula will be giving you a sum to n terms. This is a formula r is lesser than 1 and this is a formula when r is greater than 1. I hope you got this one. Here I have mentioned the formula of sum to infinite terms of a GP. That means when n is becoming infinite. So here I am taken when r is lesser than 1 formula. Sn is equal to A into 1 minus r to the power of n divided by 1 minus r. Where if r is lesser than 1, this is a formula, r to the power of n approaches 0 as n approaches to infinity. So here r to the power of n will be approaching to a 0 when n tends to a infinity. So therefore you are going to have the formula of infinite terms. Infinite symbol is denoted by like this, that is S infinity will be is equal to A divided by 1 minus r. So these are all the formula you need to remember to solve the problems on GP. Now we'll move on to the solving the problems on GP, how they have given. Here they have asked directly the 2-marker question. Which element of the GP 4, 6, 8 by 12 is 81 divided by 24? Now here they have given the first term is A given as 4 and nth term they have given it as ratio. You can take it as R is equal to 6 by 4, which implies you can cancel by 2 3s are 2 2s are, which will be is equal to 3 by 2, and Tn they have given it as 81 by 4. Therefore, now you can use the formula of Tn is equal to AR to the power of n minus 1, because they have asked in which element. Element means you need to find out the n. So you are substituting the value 81 divided by 4, which implies A is 4 into Here r is nothing but 3 by 2 whole to the power of n minus 1. Now you can bring this to the form of what? 4 can be written as 2 squared and 81 can be written as how? You are going to have 81 by 4 you are having. Let me cross multiply this 4 to the left hand side. So 81 divided by 4 into 4 it will become 16, which implies 3 by 2 whole to the power of n minus 1. Now you can have here 81 by 16 can be written as, which this will be is equal to 3 to the power of 4 and this will be is equal to 2 to the power of 4. So therefore I can write 3 by 2 whole to the power of 4, which implies 3 by 2 whole to the power of n minus 1. Now according to the theory of indices, if the base are same, I can equate the powers. So therefore n minus 1 is equal to 4 or n will be is equal to minus 1 if I take it to that side, 4 plus 1 which will become 5. So therefore fifth element will be the term of the value 81 divided by 4. You understood? So this is how you are going to solve easier way by using the formula of GP. We'll move on to the next problem, dears. Which element of the GP 5, 10, 20 is 80? Here also same we can take it as, let A is equals to 5 and R is equal to ratio of the term and the preceding term, that is 10 divided by 5, which I can write it as 5 ones are 5 twos are, common ratio is 2, and then a Tn they have given it as 80. We need to find out which element will be the 80. So here same formula I am using. Tn is equal to A r to the power of n minus 1, given Tn as 80, which will be implying 5 into given r as 2 to the power of n minus 1. You can take this 80 to this side. So 80 divided by 5, which implies 2 to the power of n minus 1. So you can cancel over here. 5 ones are 5. Remaining is 3. So 5 6 are 30. I can write this one as 16 will be is equal to 2 to the power of n minus 1. 16 can be written as 2 to the power of 4, which will be is equal to 2 to the power of n minus 1. Now according to the theory of indices, the base are same. I can equate the power. So therefore equating n minus 1 is equal to 4 or n will be is equal to 4 plus 1, which is 5. So fifth element will be the 80. I hope you got this one. We'll move on to the next question, dears. What they have asked, how many terms of GP 139 will amount to 364? How many terms of GP they have asked? You need to find out the n. Okay. So here amount to 2 means they have given Sn. So let me write the given elements here. Given as Sn is 364 and A first term of a GP is 1 and R is nothing but 3 by 1, which is 3. Now by using the formula of Sn, you can have it as Sn will be is equal to, it is given by the formula. Now 3 is greater than 1, isn't it? It is greater than 1. So therefore we need to use according to A into r to the power of n minus 1 divided by r minus 1. Depending upon the r, whether it is greater than 1 or lesser than 1, we are going to use a suitable formula. So here Sn they have given it as 364, which implies A1 into r to the power of n means 3 to the power of n minus 1 divided by 3 minus 1, which implies 364 is equal to 3 to the power of 1 into anything will be same thing. 3 to the power of n minus 1 divided by 3 minus 1 is 2. So therefore multiplying this 2 in the left hand side, which will be giving you 2 4s are 8, 2 6 are 12, 1 will be the LCM, 2 3s are 6, 6 plus 1 7. So 728 will be is equal to 3 to the power of n minus 1. Now you can bring minus 1 to this side, it will become 729. So 3 to the power of n can be written as 728 plus 1, which is 729. Now you can write this 729 as in the 3 powers as 3 to the power of n will be implying that 3 to the power of 6 giving you the value 729. Now the base are same, I can equate the powers, therefore n will be is equal to 6. This is the number of terms you are going to have. Okay. This is what they have asked you to find out in this problem. I hope you got this one. We'll move on to the next problem, dears. What they have asked. how many terms of a GP 1 by 2, 1 by 4, 1 by 8 etc. will amount to 31 divided by 32. Same problem, but SN and A and R will change it here. Will depending upon the formula where R is lesser than 1 and R is greater than 1. Okay. So here we'll be writing as given terms. Given A is equal to 1 by 2 and R is equals to 1 by 4 into 1 by 2 numerator it will go 2 by 1. Correct. So 2 1s are 2 2s are, which is 1 by 2 again. So R is lesser than 1. So lesser than 1 means we are going to use the different formula, and yes, and they have given it as here 31 divided by 32. So therefore we know that if R is lesser than 1, Sn is given by A into 1 minus R to the power of n divided by 1 minus R. So therefore A we know that it is 1 by 2 into 1 minus R to the power of n is 1 minus 1 by 2 to the power of n divided by 1 minus 1 by 2. You know 1 minus 1 by 2 is 1 by 2 only. So with this 1 by 2, 1 by 2 will go. So here Sn they have given it as 31 divided by 32. We'll write it as it is. Now this will be here 1 minus 1 by 2 to the power of n can be equating to 31 divided by 32. Understood, dear students? I'm skipping one step here. Here 1 minus 1 by 2 is 1 by 2. Along with this 1 by 2, this 1 by 2 will get cancelled. Remaining is only this term. Okay. Now here I can take 1 by 2 to the power of n to this side, 31 to this side. What it will become? So 1 minus 31 divided by 32, which will be implying 1 by 2 to the power of n. Now you can multiply this one by taking LCM as 32. 32 into 1 is 32. 32 minus 31 is 1. 1 divided by 32 will be is equal to 1 by 2 to the power of n. Now 1 to the power of anything will be 1 itself. Now here I can write it as 32 can be written as 2 to the power of 5. So therefore 1 by 1 to the power of 5 is 1 only. So together I am writing 1 by 2 to the power of 5, which implies that 1 by 2 to the power of n. Now dears, you can see here base is same. I can equate the powers. What will be the term? N will be is equal to 5. That's it, dears. I hope you got this one. How to solve by using the Sn formula according to the condition of where R is lesser than 1, R is greater than 1. Last problem was R is greater than 1, and this problem here we solved R is lesser than 1. We'll move on to the next problem, dears. A 3-marker question. They have given a third and a fifth term element of a GP are 3 and 27 respectively. Find 8th element. The third term means I can take it as T3 they have given, which is 3, and T5 they have given 27. Now you know T3 can be written as one term will be lesser, which implies AR squared, which will be is equal to 3, and here one term is lesser, AR to the power 4, which will be is equal to 27. Now you can divide these two, that is AR to the power of 4 divided by AR squared, which implies 27 divided by 3. Now you can cancel this AA and R squared. One term of R squared will be getting cancelled. Now here remaining is R squared. R squared will be is equal to here 3 1s are you can cancel, which will be 3 9s are. So R squared is equal to 9 means R will be is equal to square root of 9, which is 3. Plus or minus 3, either you can go for plus 3 or you can go for minus 3. Now here I am going for plus 3 and finding out the A value. So here A value I can take the first term as AR squared is equal to 3. Correct? Now you know R is equal to 3 already. A into R is 3 squared, which implies 3. So A will be is equal to 3 squared is 9 you are having. So therefore you can cancel one term of 3, one term of 3. Remaining is 3. R will be is equal to 1 by 3. So here A is 1 by 3 and R is 3. So you are finding A by putting the R value, and then we are moving on to finding the 8th element. 8th element is given by T, that is A T8 will be is equal to AR to the power of 7. We know the A value is nothing but 1 by 3 and R value we know that 3 to the power of 7, which implies one term of 3 will go. Remaining is T8 will be is equal to 3 to the power of 6. Now 3 to the power of 6 is nothing but 729. So this is how we are going to find out the 8th element by finding out the A and R by given conditions. I hope you got this one, how to solve the problems of a GP. Now we'll move on to the next problem, dears. What they have asked. The third element of a GP is twice the second element and the fifth element is 32. Find the GP. We know that GP is given by A, AR, AR squared, etc. So here we need to find out A and R, correct? So therefore by the given condition, third element that is T3 is equal to twice the second element, that is 2 times of T2. We know that T3 is given by AR squared, which implies 2 into T2 is given by AR. Now here A and R one term R will go. Remaining is here R will be implying as 2. So if R is equals to 2 and given condition fifth element is 32. So here they have given T5 is equal to 32. T5 we can write it as AR to the power of 4 is equal to 32. We know already which is nothing but 2. Substituting that A into 2 to the power of 4 which implies 32. 2 to the power of 4 is given by 16 or you can write it as 32 as 2 to the power of 5. So A into 2 to the power of 4 is equal to 2 to the power of 5. Here one term of 2 will go, 4 term of 2 will go. So remaining A value will be is equal to 2. So here A value is also 2 and R value is also 2. Now writing the GP is given by A, AR, AR squared. It will continue as it is. Therefore, you can write it as 2 into 2 is 4, 2 into 2 squared. 2 squared is 4. 4 2s are 8, correct? You can observe, dear students, 4 by 2 is 2, 8 by 4 is 2, it will continue as it is. Next term will be 16, 16 by 8 is 2 again. So ratio will be constant. So this is what they have asked you to find out. I hope you got this one. We'll move on to the next problem, dears. What they have asked. Find the 3 numbers in GP whose sum is 39 and their product is 729. Now 3 terms of a GP, here I am considering as let A by R and AR be 3 terms or 3 numbers in GP. So given that their sum is 39 and the product is 729. Let me do the product here. A by R into A into AR is equal to 729. Now you can cancel over here A into A, it will become A cube. A cube will be is equal to 729. Dear students, 729 can be written as 9 to the power of 3. Here powers are equal. I can equate the base, that is A will be is equal to 9. If A is equal to 9, they have given also the sum. Sum means addition, that is A plus A by R plus AR is equal to 39. You can substitute the value of A there, which is 9. 9 plus 9 by R plus 9R is equal to 39. Now you can take the LCM as R. So therefore, you can get or multiply throughout by R. You can get 9R plus 9 plus 9R squared is equal to 39R. Otherwise, you can take 39R to this side. It will become 9R squared. 9R minus 39R, it will be minus 30R. So, minus 30R plus 9 is equal to 0. Now, you can multiply this 9 nines are 81. If you multiply, you should get 81. If you add or subtract, you should get minus 30. Now, otherwise you can divide throughout by 3 here. It will become 3R squared minus 10R. See, divide throughout by 3, 3R squared minus 3 tens are 30R. So minus 10R plus 3 is equal to 0. Now if you multiply, you should get, what is that? A 9, and if you add or subtract, you should get 10. So here 3 3s are 9, but 3 plus 3 is 6. Only one condition is remaining. 9 1s are 9. 9 plus 1 is 10. So therefore I can take it as 3R squared minus 9R minus R plus 3 is equal to 0. Otherwise, I can solve like this. See, this I can solve it as 3R squared. So what I can take common here? 3R. If I take 3R into remaining is R. 3 3s are 9. So 3 it is remaining. Minus 1 into R minus 3 is equal to 0. So therefore, equating that 3R minus 1 equal to 0, or I can equate R minus 3 is equal to 0. So therefore, you are getting 3R minus 1 equal to 0 means R will be is equal to 1 by 3, or R will be is equal to 3. These are all the two values they have asked. Find the three numbers means when R is equal to 1 by 3 and A is equals to what? 9 we need to find out. Therefore, you can find out here when A is equal to 9, R is equal to 3 you find out first. That is A by R, that is 9, comma A by R, that is 9 by R, that is 3, comma which is AR, that is 9 into 3, which implies 9, comma 9 by 3 is 3, 9 3s are 27. You can take it as R is equal to, A is equal to 9, R is equal to 1 by 3. So A is nothing but 9, comma A by R. A is here 9. 9 divided by 1 by 3. 3 will go to numerator, comma here 9 into AR 1 by 3. So which will become 9, comma 9 3s are 27, comma 9 3 1s are 3 3s are. So 3. Either this or this in an increasing order or a decreasing order you can write it as. So taking any one value of the R, you are going to get the answer. I hope you got this session, how to solve and how to find out the common ratio if they ask. They can ask to find out the common ratio for one marker. So you know how to find out the common ratio, that is the ratio between the term and its preceding term gives you the common ratio. And based on that we have solved so many problems here also. I hope you got this session, how to solve the problems based on the sum to n terms or the nth term of a GP, or when they have asked you to find out the three numbers by the given condition of a GP. So in the next session, we'll be moving on to some more problem solving on the progressions. Thank you dears. Have a nice day.